For generations, one of humanity's biggest questions has really centered on Mars, our closest planetary neighbor. We've seen all this evidence, undeniable signs of ancient rivers, lakes, but today it's just this cold, barren desert. So what happened? That transformation, it's been this like huge mystery, a real scientific detective story. Well, today on the deep dive, we're going to pull back the curtain a bit. It's a fascinating new clue, something NASA's rovers have unearthed. Our deep dive today is looking at recent research, including a pretty pivotal article in Science Alert by Daniel Lawler, AFP. Came out just a few days ago, July 6th, 2025. And this isn't just, another piece of data. It's a discovery that could really fundamentally reshape how we see Mars's past, why it's so inhospitable now. So our mission today, let's unpack this, understand what it means for Mars, and crucially, how it connects to that grander search for life elsewhere. Okay, let's dig in. Right, so let's start with that core puzzle. We know early Mars was wetter. The geology, it screams rivers, lakes, but look at it now compared to Earth. So different. What was the secret?
What changed so dramatically?
Well, what's really striking and very recent is a discovery from the Curiosity rover. It found rocks just packed with carbonate minerals. Now think of carbonates. Well, they're kind of like limestone here on Earth. And their critical role is acting like this natural sponge, basically. They pull carbon dioxide straight out of the atmosphere and lock it away inside the rock. This is a huge piece of the puzzle, because CO2 is such a potent greenhouse gas.
Okay, so it's not just finding a new rock type then. There's this new study, right, in Nature. It models how these carbonates could totally rewrite the climate history of Mars. The lead author, Edwin Kite, he's a planetary scientist at the University of Chicago, also on the Curiosity team. He describes these watery times as like blips of habitability or brief oases. What's the significance of him saying they were the exception, not the rule?
Yeah, that's a really crucial distinction, because when you connect it to how planetary climates work, the difference between Earth and Mars just leaps out at you. See, on Earth, we have this beautifully balanced carbon cycle. CO2 warms the planet, sure, and yes, some gets trapped in rocks. But, and this is key, our active volcanoes constantly pump new CO2 back into the atmosphere. It's this steady volcanic outgassing. It maintains a stable climate over the long haul, billions of years of liquid water. Mars, though, Kite points out it had a feeble rate of volcanic outgassing compared to us. It's like the planet's thermostat was just constantly losing power. Without enough new CO2 getting released to sort of top up the atmosphere, Mars just couldn't hold on to its warmth. So over time, the atmosphere thinned, the planet got colder, much less hospitable.
Wow. That's a staggering implication then. So based on their modeling, this geological imbalance meant what? Brief windows of water, followed by these vast stretches, you're saying up to 100 million years of just barren desert? Think about what that means for anything, trying to get started, trying to survive there. That's an incredibly harsh reality.
It absolutely is. It really makes you question the persistence needed for life. Although, Edwin Kite does note, it's still possible there could be pockets of liquid water, maybe deep underground where conditions are different. And, it's not just Curiosity hinting at this. NASA's Perseverance rover landed in 2021. It also found signs of carbonates right at the edge of an ancient Martian delta. So the evidence is building. The whole scientific community is now really focused on finding more of this carbonate stuff. Of course, the ultimate confirmation, the best proof, as they say, would be getting actual rock samples from Mars back here to Earth. And that's a race, Both the U.S. and China are really pushing to make that happen in the next decade.
Okay, so stepping back from Mars itself for a second. What does this understanding mean for that bigger search? Life out there in the universe. This insight from Mars, it gives us critical context, doesn't it, for that huge question. How common are planets like Earth, planets that can really support life long term?
Well, it's fascinating because, we've found nearly 6,000 exoplanets now, planets outside our solar system, but Mars and Earth, they're still unique. As Kite highlights, they're the only two planets where we can actually get our hands on the rocks, study them directly to piece together their past. So Mars really serves as this natural laboratory for understanding planetary habitability. It's invaluable.
Right, and Kite seems to draw this critical line in the sand, depending on what we ultimately find or don't find on Mars.
Yeah.
He says if we figure out Mars never hosted even tiny microbes, even back in its wet periods, well, that suggests maybe starting life is actually quite difficult across the universe. But if we do find proof of ancient Martian life,
then, yeah, he says it would basically be telling us the origin of life is maybe relatively easy on a planetary scale. a profound difference. Exactly. It just underscores the immense significance here. This isn't just about Mars's history. It's about using Mars to sort of calibrate our expectations, our understanding of the cosmic odds for life. It gives us context for judging the habitability of all those thousands of exoplanets we keep finding. Mars is just this crucial, irreplaceable piece in that huge universal puzzle.
So wrapping it up, the key insight seems to be this. Mars is barren today, despite that ancient water, maybe because its geology just wasn't active enough compared to Earth's. That feeble volcanism, as Kite called it, it prevented a stable, long-term water cycle. It couldn't keep the planet warm enough consistently. So even with those carbon-absorbing minerals that carbonates, it just led to these brief blips, these oases, but never the kind of long-term cradle for life that Earth became. So here's something to think about. What does this new picture of Mars, this understanding, mean when you look out at those nearly 6,000 known exoplanets? Does it make life out there feel rarer? Or maybe more common? If the spark is easy but the persistence is hard? What does it really take for a planet to move beyond being just a fleeting oasis and become a true, enduring cradle for life?
For generations, one of